Yes. So on here, this is just kind of like the overall concept of everything. So when it says exam review, this is like just non-multiple choice, making sure you understand the concepts behind things and what something is asking you to describe. So for example, here, like number one is actually a pretty easy question. Okay. It's just making sure you understand this would be on a non-calculator part, that you understand that this is a quadratic model, correct? Yes, it's a quadratic model that is touching where? It's touching at -4. That's the main concept here. Is that do you realize that this is just simply a quadratic touching at -4 and it's positive, so it's going like this. Okay? So when you are describing it's where it's increasing and decreasing, that's why it's a simple question. What makes it hard is just you remembering what it looks like and what that represents. Okay? So where it's increasing, guys, when we're writing intervals of increase and decrease, which it goes against my soul completely, we're using brackets and brackets for numbers, parentheses for infinity. So we're increasing from, what is it, -4. So this should be a bracket. See how hard it is for me to almost put parentheses, and to positive infinity. And we are decreasing. I can spell. We're decreasing from left to right. So we're decreasing from negative infinity up until we get to -4. Okay. So the problem is not meant to be hard. It's just to make sure that you understand what is asked of, what is asking you of. Okay. If you need to leave, I'm recording this. So it will be recorded and I'll keep going until 7:30. So, all right. All right. So up next is average rate of change. A-Rock. How do we find A-Rock? Exactly. You're finding your input, your output divided by your input. So we have G of 4 minus G of -2 over 4 minus -2. Okay. If I set it up like this, it helps me make sure that my numerator and my denominator are matched up. G of 4. When I plug 4 into this equation, what do I get? 4 squared is 16 plus 2 is 18. When I plug -2 in this equation, what do I get? 4, and 4 plus 2 is 6. A negative times a negative is a positive, so it becomes 4 plus 2, which is 6. So 18 minus 6 gives me 12 over 6 gives me 2. Should we miss average rate of change problem? Absolutely not. Huh? Would you say, Jessica? No, no, it cannot. It cannot. I refuse to hear that. We should not miss absolute value problems. Okay. Okay. All right. So next here, this graph, it says the graph of h of x is shown in a figure, right? From the interval from -6 to +6. Okay. That's all we're looking at. On that open interval, is h increasing? Is it increasing? If so, yet where? So yes, it's increasing. So h increases from where? Yeah. To where? Oh yeah. To where? Where do I stop at? -4. Remember, intervals of increase is used with your x values, not what your y value is. All that matters is your x. So this starts at -6 and it stops at -4. So my first interval of increase is from -6 to -4. Yes. And then where is another interval of increase? Because it says what open interval? Oh, I don't know. Because I asked you guys, is it increasing anywhere? And you said yes, so I wrote yes. That's why. To my question. Overall, the concepts that we've learned all year long. Okay. Easy. See, we're starting off. This was all the way back in August and September. Y'all remember this a little bit? It's in your brain. I know it was a while ago. Um, FRQ is going to be describing like increasing tied to rate of change. So that's where your concavity comes into play.
So I can just explain it.
Yes. So because it's concaved up, it's a blah, blah, blah. It's increasing from blah, blah, blah. Yeah. All right. Identifying zeros in their multiplicities. Remember, x's are liars, so it's already in factored form. So we know our zeros are where? -5 and 3. So it says describe the multiplicity. So starting with the first one, what is the multiplicity for -5? At x equals -5, and we have a multiplicity of 1. It depends on the power outside of the factor. And since there's nothing there, it's cast with a friendly 1. Okay, and we have another one at what? X equals +3, and it has a multiplicity of what? Of 2. Okay, so this is going to be, it crosses the x-axis, right? So we cross, and here we touch, kiss, whatever you want to remember it as, because it is tangent to the x-axis, okay? That's what the multiplicity and even multiplicity tells us. Okay, next is limit notation. So use limit notation to describe the end behavior, okay? In order to describe the end behavior, we have to describe the function overall. So remember Bob and his 4 dance moves? You all remember Bob and his 4 dance moves? Yes, exactly. He's waving his hands, waving up. He shimmies down. He's staying alive. Those are all he got, right? That's all Bob got, right? Okay. So in order to do that, in order to decide what Bob is, we have to look at 2 things, the degree and the leading coefficient, okay? So in this case, our degree is what? Our degree is 3, and our leading coefficient is going to be positive or negative. It is a positive. That's all that matters. So Bob, his right-hand side is going up, and because his degree is 3, his left-hand side is doing what? Going down, because it's odd. So Bob is doing something like that. Oh, LC, leading coefficient. Thank you. Okay. So therefore, now we can describe from left to right as x. Oh, sorry, I'm writing for algebra 2. You don't see that. Limit notation, limit notation. I've been writing it for algebra 2. So the limit as x goes to -infinity. That's our limit notation. What are we describing? F of x equals what? -infinity. As the limit of x goes to positive infinity, f of x does what? Goes to positive infinity. Yes?
You have to write.
No. I had started writing it as if I was teaching algebra 2. Do y'all remember in algebra 2 we had to write them as sentences as x goes to positive infinity? We did limits, just a little bit of the limit, but mainly we didn't do limit until breakout. All right. But are we good?
Yeah.
Bob only has 4 dance moves, guys. Okay. His dance moves depends on the degree and the leading coefficient. That's it. All right. It's a lot. All right, here we go. Next is writing the equivalent factor form. So that means you have to remember how to factor. You okay? Oh, okay. Remembering how to factor, okay? So in this case, our numerator, you have 2 options for factoring here. You either can factor using quadratic formula if you suck at following grouping or Xbox. Yes. No, this is a horizontal asymptote at 2. But good try. I love your confidence in trying to give me that. But factoring this. So if you choose to do the Xbox method, do we remember the Xbox method?
Yeah.
What multiplies to give me -18x squared, but adds to give me -3x. So what multiplies to give me -18x squared, but adds to give me -3x. What kind of 6 and 3? A -6x and a +3x. -6x times 3x makes -18x squared. -6x plus 3x makes -3x. So therefore, these 2 work. You either can do grouping from here or you can do the box. Y'all remember the box? The 2 by 2. Your first term goes in the first box, your last term goes in the last box, and your numbers that work go on the empty boxes. You either can do that. If you do not remember this, let's all sing the quadratic equation. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Hey, x equals negative b plus or minus the square root of b, that's not a b, of b squared minus 4ac divided by 2a. Hey, do we remember? Okay. So if we were to do it this way, then it would go, you can go. Okay. So again, Alana. So we have negative 3 plus or minus the square root of negative 3 squared minus 4 times 2 times negative 9 all over 2 times 2. So if you're not good at factoring, the quadratic formula is your friend. If you are good at factoring, then you don't need the quadratic formula. If in this case, now all you're doing is GCF. Remember, once you're in the box, it's just GCF. The GCF of this row is X. The GCF of this row is negative 3. The GCF of this row is 2X. The GCF of this row is positive 3. So your factors are 2X plus 3 and X minus 3. So that's your numerator. So 2X plus 3 times X minus 3. Your denominator is a difference of 2 squares. Does that ring a bell? Nope, it's plus, it's minus, not plus. So it becomes X minus 3 and X plus 3. Difference of 2 squares is only if there's a plus, is there imaginary. Okay?
If it was two plus,
If it was X squared plus 9, then that would be a complex number.
what would the complex number be? 3i.
It would be an, exactly.
3i and so.
Yep.
And be x plus.
Mhm.
And then you have to have.
Yep, because you have to have complex come in pairs, right? All right, so if you did not remember this, then this is your other option. If you chose to do the quadratic, you have 9. You have 4 times 2 is 8. 8 times negative 9 is 72. All over 4. That gives you 3 plus or minus the square root of. Did I do that math right? 81, right? Square root of 81 is 9. And 3 plus 9 is?
Plus 9 is 12.
And 12 over 4 equals 3. All right. So that's 1. So therefore the factor is X minus 3. And then the next one, 3 minus 9 is? 3 minus 9 is negative 6 over 4. Gives you negative 3 over 2. So your factor here would be 2x plus 3. And is that what we got from the box? Yes. Okay. This is faster. But if you're not great at factoring, say boy, be a ghost. Yes. Yes. But you're distracting them from making a grade on their AP test table. Be quiet. All right. So now once you're factored, you can determine whether you have vertical asymptotes or holes.
Yep.
We have one hole. Why do I have a hole? I'm writing in the wrong spot. And y'all were just going to let me? Okay, thanks.
Okay. So that positive 3.
At x equals 3. Agree? Because it's in the denominator and in the numerator. And x's are liars. Okay? All right. To find the coordinate of the hole, let me know when y'all are ready. When you find the coordinate of the hole, that means you're plugging this in after you've eliminated it. Okay? So to find the coordinate of the hole, I'm going to plug in x, 2 times 3 plus 3 over 3 plus 3. I already have the x. I now need to find the y. Okay, so that's 6 plus 3 is 9. 3 plus 3 is? So 9 over 6 gives my y value where? 3 over 2.
You said 9 over 6, right?
9 over
I'm
6.
tripping, never mind.
So therefore the ordered pair for the whole would be 3, 3/2. Does that make sense? Okay. Now, next thing we know is that we have a vertical asymptote because what's left in my denominator? Vertical asymptote at what then?
I make -3.
-3. Okay. Now, Alana, would you like to redeem yourself on the horizontal asymptote? Horizontal asymptote. Where is it at?
2x. It's gonna be y equals 2x.
Can't have an x. It's just y equals your coefficient. The coefficient in the numerator is, the coefficient in the denominator is. So therefore, it's just y equals 2. It's just 2. You're just left with 2. You have 2x plus 3 over x plus 3. Maybe you should stop talking so much. Okay? The degree of the numerator and the degree of the denominator are the same. So all you're doing is taking their leading coefficients and dividing them. The leading coefficient of the numerator is 2. The leading coefficient of the denominator is 1. And unlike Alana said, 2 divided by 1 is not 3. 2 divided by 1 is 2. So your horizontal asymptote is at y equals 2. Okay? Your zeros of the function, your zeros come from your numerator. Okay? So you take what's left in your numerator and set it equal to 0. So what's left in my numerator? 2x plus 3. So we're taking 2x plus 3 and we're setting that equal to 0. So therefore my 0 is where?
-3 over 2.
-3 over 2. Okay? It says zeros, not x-intercept. So that means you also have to find your y-intercept. Your y-intercept means that all you're doing is letting x equal 0. When I let x equal 0, what am I left with? 3 over 3 is what? 1. So therefore my y-intercept is at 0, 1. Okay? So we now found all of our zeros. We found our x-intercept and our y-intercept. We found our zeros. These are all the things that you need to be able to do with a polynomial function. Because they're all fair game for a multiple choice question without a calculator. What are your questions, comments, or concerns you may have for me?
That was a great review.
Okay. So, does this look familiar from our Kahoot? Okay, let's see if we can get this one right. What type of zeros do I have? Okay, how many? How many reals do I have? I have 2 reals. And what are they? Good. Okay. And then I have one what? One complex, one imaginary, right? And what is it?
It's x plus 4i and 8.
Oh, yeah.
Am I wrong?
X squared plus 4 equal to 0, right? So we subtract and we're left with x squared equals -4. We take the square root, and what is the square root of 4i? No, 4 of -4.
Plus or minus 2i.
Plus or minus 2i. Okay?
I thought it was plus or minus. Question.
You still have to take the square root of the 4. Yes.
For x equals 0.
Mhm.
No, Well, the x is 0, is it the x squared?
It's the x squared. Remember, this is a one-term factor. When you have a one-term factor, that means the zero is automatically at 0.
Yeah, only part of the 2, I understand.
It's, oh, my minus didn't stay.
I was about to say.
Okay. X equals 0 has a multiplicity of 2, and everything else has a multiplicity of 1. Does that make sense? Because x is squared. Okay. The next part is saying, can you work backwards? Can you create the factors from given information? So if I told you here that I have a polynomial with real coefficients having the degree of 4, my zeros are negative 2i and 3 with a multiplicity of 2. Okay. So to begin with, I'm going to write my first factor. What would be my first factor? So given the first information, negative 2i, what would its factor be? Jill. It would be, I mean, it doesn't really matter. But if you have a negative 2i, that means you also have to have they come in a pair, right? So if you're given one, you automatically know that the other one has to be there. Okay. All right. And then 3, what does that mean about the multiplicity? What is its factor? What is its factor? If I have 3, what's my factor? There we go. Do we see how we went backwards? Okay. Now, if it asks you for the polynomial, so we wrote it in factored form. Now it says write as a polynomial. Writing as a polynomial just means you have to use your multiplication skills. That is it. Can we multiply? Okay, you're going to multiply your complex factors together, and that's because it's going to eliminate the I. Does that make sense? So when I multiply my complex factors together, I'm going to be left with x squared plus 4. When I multiply x minus 3 squared, I'm going to be left with x squared minus 6x plus 9. Do we see where that comes from? Simply foiling. And now to find the final polynomial, you're going to multiply each one of these. You're going to do multiple distribution. So following multiple distribution, we have x squared times x squared gives us x to the 4. X squared times negative 6x gives us negative 6x cubed. X squared times 9 gives us 9x squared. Now we have 4 times x squared, which gives us 4x squared. We have 4 times negative 6x, which gives us negative 24x. And we have 4 times 9, which gives us 36. I personally stack mine so that I can easily combine like terms. You can write yours all in a row if that's what your heart tells you. I have x to the 4th minus 6x to the 3rd plus 13x squared minus 24x plus 36. And that would be my completed polynomial.
Wait.
Yes, no, maybe so.
Go this way.
It just felt long because we went kind of slow. But all you're doing is multiplying coefficients and adding the powers, right? How do we feel about going backward? Yes.
Because it says 9.
Mhm.
9x2. Do you add that?
Yes, I added that to the 14x. I combined the like terms.
Yeah.
Yeah. All right. All right, moving on is describing our behaviors. So it says here the extrema for F are labeled A, B, C, D, okay? And E represent X coordinates at these points. On which interval is the rate of change positive and increasing? So on what interval am I positive and increasing?
D to E.
It's D to E. Do we see why?
That's because D to E is a
A
concave
to
up.
A to B is a concave down.
There we go. So it is increasing and concave. There we go. Okay, let's try the next one. Ready? It says, on which interval is the rate of change negative and decreasing? Negative and decreasing. B to C. Draw Bolano. Okay.
Everybody get five.
Huh?
C to D.
C to D. So C to D is concaved up. Yeah, C to D is concaved up. But it says because we're negative and decreasing, we need to be concave down. So F is decreasing
Yeah, you got some.
and concave down.
Why'd you say you wanted them?
All right, here we go. On what interval X is the function increasing at a decreasing rate? Increasing at a decreasing rate. A to B, there we go. There. This is A to B, and that's because F is increasing. You can take some. I don't know. Put it in the fridge for tomorrow. Okay.
Whole pack? Hey, actually, that's me. You can take it.
You know, I think
Yeah, I was
gonna
say,
take the
like,
bread. Take the bread.
You take it. It's gonna be sell by tomorrow.
Yeah, take the bread.
I'm really.
Yeah, don't let it go to waste.
Never
Bye.
wait.
Bye. Okay. And that's because we're increasing in concave down. Does that make sense? All right. Last one. On what interval are we increasing at an increasing rate? C to D. Okay. F is decreasing and concaved up.
Yo,
Sounds fair.
Max, why are you against extra credit?
we included the extra. I'm trying to learn, but I'm trying to be for fun at the same time.
All right. And I feel like I should have wrote here on this one. I did not talk about concavity. So let me add that in there. So F is increasing, but F is increasing in concave down.
See, concavity isn't where I'm having trouble.
But we're good, right?
Yeah, I just
Wait, can I write these down?
Yeah.
I know it. I know.
I think we had a little brain fart in the beginning with concavity, but once you see it's just about looking at the curves, then it makes it easier. Okay. Y'all all did after that quiz. I was like, what is going on?
I was surprised that I did it decent. I think I don't remember that back far. Again, thank you.
Mhm. Oh my gosh. Oh, I forgot to check.
Oh, x minus 3. I mean, x plus 3. I mean, x equals 3.
Yeah, you get it. Yeah.
All right, here we go. So here, this is going to rational functions. At this point, I feel like you guys should be able to do this without me. Finding your asymptotes, because we already did one together, right?
Yeah.
So you can go back and do it without me, correct?
Yeah.
And describe your limit, okay? What I do want to point out to you on this one is that it has what type of asymptote for instead of horizontal? Why is no, it has a what? A slant asymptote, okay? What I do want to remind you is to find slant asymptote. That's the main thing I want to talk about here is that you have to do long division or synthetic division. I don't really care which one you do, but you need to do division, okay? That's because the degree of the numerator is greater than the degree of the denominator by 1 degree. So long division, remember you're setting it up, x minus 3, and you have your 2x squared minus 5x plus 8, and you're talking to yourself, okay? Remember, does McDonald sell burgers? Okay, what that means is you divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. So we're dividing. So 2x squared divided by x. What is that? Subtract, bring down. Divide, multiply, subtract, bring down. This quadratic formula. It's just going to be 2x. Okay, after we divide, we then multiply. So 2x times x gives me 2x squared. 2x times negative 3 gives me negative 6x. We subtract. When we're subtracting our polynomials, that means you're changing their signs and combining. Okay, so what happens here?
Good.
And then we get what? And then we bring down. And we do it all over again. You all remember now? Okay, so we're going to do it again. Divide. So we ask ourselves, what is 1x divided by x? So it's 1. And I really don't need to go any further because I want you to go again. So this is my slant asymptote. Oh, cut it off. Your slant asymptote is before the remainder. We don't care about the remainder. Your slant asymptote is before the remainder. Who told you that? They lied to you. Your slant is your quotient. Your quotient, not your remainder. This is my quotient. Okay. So if I was to keep going here, my remainder would be 11, right? So this would be 11 out of x minus 3. That is not my slant. My quotient is my slant. This is my remainder.
Maybe I'll rethink it.
Okay, so my slant asymptote
Glad we're going over this because I probably
is y equals 2x plus 1. Okay, did we see that? That was the main thing I wanted to go over with. At this point, you should be able to factor without me. I believe you can. You don't really need to factor here, but no. But I'm gonna say all I really wanted to touch on was the long division. Okay. And a reason why I had to do long division was because the degree of my numerator is greater than the degree of my denominator by 1 degree. Yes. Okay. All right, let's move on. So polynomials just keep going. We spent a lot of time on polynomials in the fall. So this one is about being able to read the multiplicity from the graph. So if they give you a graph, can you tell me my zeros and describe their multiplicity? Okay. So I'm going to just do it from left to right, and it's not a kiss at 0. So left, my first 0 is here at x equals -2, and it has a multiplicity of 1. Next, I'm here at 0. At 0, that's a drive-by. So therefore, it has a multiplicity of 3. Okay, then again, I'm at 2. at x equals positive 2, and it has a multiplicity of 1. Okay, so I wish we had. We would have been doing this on Thursday, but I had to give y'all that darn test. I wasted our time. We're not. All right, so K of X. Is K of X negative or positive? Why am I negative? The right side. The right side. So I'm starting off negative, and then I'm going to write my factors based on what I identified my zeros to be. Okay? So we had X equals negative 2. So what is its factor? Perfect. We had X equals 0 with a multiplicity of 3. So what is its factor? The drive-by. It's just X to the third.
What? I remember I said that they're kissing. You said no, it's drive-by. I don't remember.
All right. X equals 2 is a factor of and a multiplicity of 1. So that would be the most. Okay. And then at that point, if I had to write it out, could you then multiply without me? Yes. I'm not going to multiply for you. The main thing is that we can write it as a factor, and then you can do your multiple distribution on your own, correct?
Yes.
All right. Next, we're going to be talking about extremas. When I say extremas, what do I mean?
The relative minimum.
There we go. We're talking about our relative minimum and maximums, okay? Or local. So it may say local or absolute. It doesn't really matter. As long as we know the extrema means you're describing your minimums and your maximums, right? So at which point does the graph of F have a local maximum? C and where else?
No, A, sorry. Is it A?
What did we see? I agree.
Oh! All three! All three, baby! All three, baby! Oh my gosh.
Something's wrong with her. It said local, so it can be more than one. Now, it says global or absolute. So your absolute extrema. Your absolute max is what? E. And your absolute minimum is? Make sense? Are we good with vocabulary? Are we good with extrema?
Okay.
I would. I didn't think A was right.
Okay, well, I'm still going.
I'm saying I'm
Okay.
apologizing.
Yeah.
Why is not F? I'm sorry.
You know what?
F
Yeah.
as your absolute?
No, for question 20.
Because it just said for maximum. It says local max, not local min. It's A also. It's a point where you increase and decrease. So you're looking at at what point do I decrease from an increase?
So theoretically, F would also be a local min.
If we ask for local min, our mins would be B, D, N.
So even the absolutes counted as local?
Yes.
Okay.
Yes. Your absolutes are counted as local. All right. Yes. Okay. Moving on. So on here, we are doing function notation, function transformation. So when you have function transformations written in function notation, that's going to be your whole thing. So you would have your A, F of your B, your X, minus your C, plus your D. And each one of these pieces play a role, correct? Do you remember those? Okay. Which ones affect your Y?
Oh, I'm sorry. Which one's affect our
F
Y?
and D?
F has nothing. F is just the name of the function.
Would affect our Y.
A and what else?
D.
And D. A and D affect your Y, right? And therefore, B and C are affecting our X. Okay? And our X's are what? Liars. Okay, our X's are liars. Okay, does that make sense? All right. So based on what we know, describe my transformations here. What was I given?
So, also a dilation by 1/2.
What kind of dilation? What kind of dilation? Is it an X or a Y? X. So therefore it's a horizontal dilation. So we have we have our B equals 1/2, which means that we have a horizontal dilation. Agreed? By how much? By a factor of 2. There we go. Because our X's are liars. Okay. So it's actually a stretch, right? I'm relaxing my accordion. It's going, it's drooping. Okay. Next, we're given our C. Our C equals what? Our C appears to be a positive 5, but is it a positive 5? No. We have a horizontal translation. And what direction am I going?
Right.
5. What direction am I going?
Oh, you're going right.
What's the left?
To the left.
Oh,
There we go.
I was looking at that one as well. I'm not even going
You said X minus.
Okay. Remember, our X's are what? Liars. Okay. So in this case, we are doing everything the opposite of what we see.
Yeah, that.
Oh, so I thought it'd help you remember.
It did, but
I got confused. That's why I
I was only focused on that one.
Oh, yes.
I'm sorry, that was on.
Okay, but we know not to make that mistake,
Yes.
right? Okay.
I'll make sure not.
B and C affect our X, and X's are liars. A and D affects our Y's. Why lie? No point. Okay.
If we had a write down, would we just put a word, 5 units, right?
Yeah.
So you just can't say stretch or compress. You have to say
Exactly.
that.
Dilation. And by a factor of blah, blah, blah. But we know from algebra 2 that that's a horizontal stretch, right? All right. On the next part, it is, I'm going to kind of go quickly, but you're given a table to evaluate from, right? So you're given a table, which is your f of x, okay? Your g of x is the transformation of that table. Does that make sense? Okay. Your f of x is the table. Your g of x is the transformation of that table. Fine. Make sense? Okay. So when you not this g of x, the one here, I'm sorry, I went up there. So this says g of x equals 2 times f of x minus 2 plus 1. So at g of 2. So it's asking you to evaluate this function at this value being substituted in. And you're going to substitute it in first and then use the table. So we're looking for g of 2, which equals 2 times f of 2 minus 2 plus 1. So that gives us 2 f of 0 plus 1. So I'm going to go to the table, go to 0, and what do I get? Negative 2. So for f of 0, I'm plugging in negative 2. Does that make sense? 2 minus 2. Yes? So we have 2, negative 2 plus 1, and that gives us what?
1. Oh, wait, you multiply that.
Mm.
4, negative 3.
Negative 3. Okay? Do we understand using the table to evaluate? Yes. Did you not submit your screenshot? Or you just did it after I put in the first round of grades?
I'll check right now.
Your D was so
I'm sorry.
Polar.
Yeah.
Polar's a beast.
I was playing with their grass. I was making like flowers and designs.
Yeah,
That
me
was so
too, because
cool.
I literally did not know. Also, I didn't
The
know.
roses.
Yeah, I like the roses and stuff. I was like controlling how many roses there was.
Yep.
Also,
All right. Again, I'm gonna leave you to practice evaluating, but do we see how we evaluate it using the table? All right. What I want to get to is the inverse one. Okay. So our inverse here, we have H inverse of 3. Okay. So when I'm looking for the H inverse of 3, we're going to be going backwards. Yeah. So if I'm going backwards, I'm going to have to figure out what. Tell me what I should do.
go on back
Mm-hmm.
and we should start from the grass.
So you're asking yourself, when does H of X equal 3? Does that make sense? Okay. The inverse means you're asking yourself, when does the original equal 3? Because the inverse is saying your input and your output are switched.
So we divide it by 4? No.
So what could I do?
So 30 would equal 4 minus F. 3.
Yeah. So on here, you're taking this. Is that how I want you to do it? I'm gonna look at myself. No, let's do it a different way. I don't like how I did it at first. We're gonna use U substitution. I think that'll be better. Yeah. Yep. All right. So we're gonna let U equal H inverse of 3. Yeah. And we're gonna substitute it into this guy. Okay. So that gives us H. I'm trying to think of what will be a fast way for you to remember on the test. So H of U would have to equal U. Okay. In my brain, this is making sense. And we're going to play it out and see. So that gives us 4 minus F 3U equals 3. And we're going to subtract 4. That gives me negative F 3U equals negative 1. Turn it into a positive 1. So we get F of 3U equals 1.
That negative 4. Or that.
Right. Oh, I subtract 4. Let me write that better. We're going to subtract 4. And what I do to one side, I do to the other.
That's the by no real. That's not gonna be in this thing.
Okay. So we know that we're looking for when do we get an output of 1. So when we look for an output of 1, the only place we get an output of 1 is where? At negative 2. So when we get an output of 1 at negative 2, that means that our inside, this 3U has to equal negative 2.
Oh, yeah.
Is the input. So therefore, our U equals negative 2, 3. So this equals negative 2, 3. Yeah, U substitution is going to be the best. That would be the hardest I would get, is working backwards from an inverse. Yeah. That would be the hardest to get from analyzing a table.
As we figure this entire time. Okay, so
But once you have 3, hey guys, huh?
Divided by 3.
Yes. Another, now, I'll be honest with you. You're probably going to get one binomial theorem question on the whole test. Probably just one. Okay. If you were to get this binomial theorem test question, and you just forget binomial theorem, you can always just multiply. Yes, remember the binomial theorem is just a shorthand way of expanding this.
I was trying to learn how to do binomial theory the other day, and that's what I was gonna ask you earlier.
Yes. So binomial theorem is just a shorthand.
Hey, please.
So binomial theorem is just a shorthand way of expanding without actually expanding. It's the pattern of us counting down our powers. So when you are looking at 3, so on our triangle, this would be at the 1, 3, 3, 1 level. You all remember our triangle? 1, 1, 1. Is this ringing any bells? Then it's a 1 again, and then it's going to be what?
2. Oh, right?
Yes. And then it's a 1 again, and now you're at?
3.
Yes.
Okay.
Okay. So this is your cubic. So this is a cubic, quadratic. Well, not. I'm gonna write it as powers. Sorry. Do that. So this will be a factor to the third, a factor to the second, a factor to the 1, and such and such. So we're using this rule, because it's x plus 2x plus 3 to the third. So those are going to be your initial coefficients. 1, 3, 3, and 1. So you're going to have 1. I'm going to make a big space. Is that okay? Like to try to exaggerate it. Plus 3, and then plus 3, and then plus 1. Okay, so that's the beginning of it. Then after that, you're going to look at your A term and your B term, okay? For your A term, you are decreasing its power. For your B term, you are increasing its power, okay? So my A term is 2x. So it's going to become 2x to the 3, then 2x to the 2, then 2x to the 1, then 2x to the 0. For my B term, I'm increasing its power. So for my B term, it's going to start off as 3 to the 0, 3 to the 1, 3 to the 2, and 3 to the 3. And then you clean it up. So multiplying the first one. So our first term here, we have 2 to the third is 8. 3 to the 0 is 1. So we're just left with 8x to the third. PEMDAS. Exponents first, right? On to the next one. 2 squared is 4. 4 times 3 is 12 times 3 is, so 36x squared. Okay. 2 to the 1 is 2. 2 times 3 is 6. 3 squared is 9. 6 times 9 is 54. This is going to cancel out because anything to the 0 power is 1. So 1 times 27 is 27. And that is your binomial expansion. Does it help seeing the spaces? Okay. As long as you remember the first 3 rows of your triangle, you should be able to do the remaining. Does that make sense? And I don't think you'll get anything higher than a 5. So as long as you can remember, starts off as 1, 1, 1, 1, 2, 1, and then you start adding them to keep going, right? Are we comfortable continuing the triangle? Pascal's triangle. All right. Remember for sign analysis, in order to do a sign analysis, it has to equal 0. So before I can do a sign analysis, I have to make this equal to 0. In order to make this equal to 0, I'm going to subtract 12. So I'm left with x to the third plus 3x squared minus 4x minus 12 is less than or equal to 0. Okay? After you continue doing that, then you're going to, I'm going to finish this one page and then I'll post the answer key for the rest. Okay. After this, it's best to factor. And this is factoring by grouping. Do we see that? So factoring this by grouping, we take out 3x and we're left with x plus what? X squared plus
Wait, 3? Is it 3?
3x squared, I'm sorry, plus 1, right? I lied. Because 3x squared divided by 3x squared is, oh, I see what you said, Alana. It was me. It's late. And we're going to take out a -4, and we're going to be left with x plus 3 again. So our factors are x squared minus 4 and x plus 3. This is difference of 2 squares. So you get x minus 2 times x plus 2 times x plus 3 is less than or equal to 0. Okay, so now you can do your sign analysis. So my zeros are at 2, -2, and -3. Do we see that? Do we remember doing this?
Yeah, I remember.
And all it is your pluses and minuses, right? So if I plug in -4, this is going to be what? Positive or negative? You owe me $4, you ask for me $2. It's going to be negative. -4 and -2 makes -6. Here, it's going to be another negative, and here, it's going to be another negative. Does that make sense? And then in between here, I'm going to choose -2.5. If I plug in -2.5 here, what is it going to be? Huh? It has to be a number between -2 and -3. And the number between that is -2.5. So it's going to be a negative and a negative, and then a positive. I'm going to plug in, anytime I can plug in 0, I'm going to do what? Plug in 0. If I plug in 0, what do I get? A negative, a positive, and a positive. And then I'm going to plug in 3. If I plug in 3, we get a positive, and a positive. So we're asking ourselves, when are we less than or equal to 0? So when are my final outcomes negatives? I get a negative here, and I get a negative here. So my solutions would be from -infinity to -3, and from -2 to +2.